Hello, today we are doing mission 4, which is simplifying and ordering fractions. Today we are finding fractions that are equivalent to each other and looking at simplest form. So those are our two topics for today, equivalent fractions and simplest form. So first, equivalent fractions are fractions that are really the same or take up the same amount of space. For example, in our paper activity, we colored in half of our paper on one side. I'm going to use the highlighter instead here. When we colored in half of this, that was the fraction 1 over 2. We have 1 out of 2 pieces. But then if I folded it in half again, now we have 2 out of 4 pieces. Those are really the same fraction. It's still covering up the same amount of space. We're just dividing it into a different number of pieces. So we're looking for right now two fractions that are equivalent to 12 over 48. So we could multiply it to make it more, or we could divide and take some of those lines away and make it a more simple fraction, down to the basics. So I'm going to do one each direction. If I wanted to, I could divide by 2. It's still the same fraction. We're just drawing less lines in our shape to divide it up essentially. So 12 divided by 2 is 6, and 48 divided by 2, well, half of 40 is 20, and half of 8 is 4. So it's really 6 over 24. So 6 over 24 is an equivalent fraction to 12 over 48. If I wanted to continue on from here and continue to divide to make it smaller, that's what's actually going to get us to simplest form. But if we wanted to go the other way and multiply by a number, it doesn't matter what number it is, as long as it's the same number in the numerator and in the denominator. So if you want to multiply by 2, great. If you want to multiply by 5, great. If you want to multiply by 10, great. Doesn't matter, as long as it's the same number on the top and the bottom. I'm going to multiply by 10 on both. 12 times 10 would give me 120. 48 times 10, you're just putting a 0 on the end, is 480. Even though they're really big numbers, it's really the same fraction. It's just like dividing this up into a lot of little tiny pieces. We still have the same amount colored in. Okay? So those are two fractions that are equivalent. You can have any two fractions that are equivalent. It doesn't have to be the same ones I had. And then they want us to take our fraction 12 over 48 and write it in simplest form. That means continue to make it smaller and smaller and smaller, divide until we have the most basic numbers that we can, until we can't divide the top and the bottom by the same number. So what we need to do here is continue to divide. If you want to divide by 2, great, but think of a number that goes into 12 and 48. I know that 6 goes into both of them. 6 times 8 is 48, and 6 times 2 is 12. So 12 divided by 6 is 2. 48 divided by 6 is 8. We can continue to make this even smaller. We can divide both of these by 2. Notice I'm dividing by the same number each time. You need to do that. You can't divide 1 by 2 and 1 by 3. It doesn't work like that. Then we have 2 divided by 2, which is 1. And 8 divided by 2, which is 4. I can't divide by anything anymore. This is our simplest form of that fraction. So what you're really doing is you're reducing or simplifying by the same number in the top or on the top and the bottom. And our math words for that would be our numerator and denominator. So let's take a look at a couple pictures. It says find equivalent fractions to the center fraction. So they're giving us 6/8 to start. We need to figure out what are two equivalent fractions that are equal to 6/8. Notice you see almost the word equal in the word equivalent, because that prefix is meaning the same. So right now we have 6 out of 8 pieces colored in. So I'm going to color in here 1, 2, 3, 4, 5, 6. Then we have 6 out of our 8 pieces colored in. So in each of these other fractions, we could color in that same amount of space. Not 6 pieces, but the same amount of space that those 6 pieces take up. So I'm going to color in those on both. All right. So on this one on the left here, our pieces got bigger, but our number also got smaller. So from here to here, you guys, we only have 1, 2, 3 pieces colored in, so that would be a 3. But mathematically, how could we get from 6/8 to 3/4? Well, if we take 6/8, the 6 and the 8, and we divide them both by 2, 6 divided by 2 is 3, 8 divided by 2 is 4. So this one, we just reduced it or simplified it. From 6/8 to something 12ths, we really have 1, 2, 3, 4, 5, 6, 7, 8, 9. We have 9 twelfths. We don't have a whole number that we can multiply. 8 times nothing is going to give you 12, not a whole number anyways. But if we go from the other fraction that we already know, this one over here, 3/4, could we go from 3 to 9? Since these are equal already, 3 times 3 is 9, 4 times 3 is 12. It's the same number. Those are equivalent fractions. They are all equal to each other. So which fraction is in simplest form or made the smallest? They're all the same size. That's not what I mean by in terms of shading it in. In terms of the actual numbers, we can't make 3 and 4 any smaller. We can't divide them by anything to reduce them. So 3/4 would be in simplest form. All right, next they want to know, are these fractions equivalent? Yes or no? If they're equal, we're going to put in equals. If they're not, we're going to show which one is greater. So there are two strategies. We could first just simplify both fractions. This one, I can't simplify anymore. 3 and 5 are both what we call prime numbers. You can't divide them by anything else. 15 and 25 we can simplify though. I know that 5 goes into both of those. So 15 divided by 5 is 3. 25 divided by 5 is 5. So are these equivalent fractions? 3/5 and 3/5? Yes, those are equal to each other. So you can write yes or just put an equal there. Another way that we can do this, instead of simplifying our fractions, is to just go from one number to the next. From 10, always start with the small one, the smaller fraction, 4/10, and then we have 10/30. To get from 10 to 30, I could multiply by 3. If I do the same on the top, multiply by 3, 4 times 3 would really give me 12. So this one would really be 12/30 over here. Those are not really the same fraction. Those are not equal to each other. So what we really did here is we figured out that these are not equivalent. So the equivalent fraction that we found, 12/30, if we multiply by 3, is actually giving us a larger fraction than 10/30. So 4/10 is greater because if we've multiplied them both by 3, we got 12/30. Let's do another one just like that. I'm going to actually use this first strategy that I used up here in simplifying both because I know 6 times nothing is going to give me 16 and 3 times nothing is going to give me 8. So I'm not going to use that strategy. So I'm going to just simplify both fractions. I can divide the 3 and the 6 by 3. 3 divided by 3 is 1. 6 divided by 3 is 2. On the other side, 8 and 16, 8 goes into both of those. So I'm going to divide them both by 8. As long as you're dividing the top and the bottom by the same number, you will get an equivalent fraction or an equal fraction to what you have. 8 divided by 8 is 1. 16 divided by 8 is 2. So these fractions are equal to each other. Last one, let's simplify. 24 and 40, I know 4 goes into both of them. I'm going to divide by 4. 24 divided by 4 is 6. 40 divided by 4 is 10. 10 times 4 is 40. But we can simplify this even more. We got to keep going until we get to even smaller numbers. They're both even. If you ever have two even numbers, we can divide them both by 2. That gives us 3 over 5. And then on the other side, these are both multiples of 10. So 30 divided by 10 is 3. 50 divided by 10 is 5. So between these two fractions, 3/5 and 3/5, they are equal. All right, I know we went a little bit quick there, so those two strategies, you can simplify both, or you can multiply to get from one number to the next. If you end up with the same exact fraction, you know they are equivalent. Next, it says solve the equation by using equivalent fractions. So we already know this fraction here. It says start with the fraction that you know. We know that's 8 over 24. We need to figure out what would go here to make them equal. So from 24, it says again start with the fraction you know, this one over here on the left. From 24 to 12, well, we're getting smaller, so we're not multiplying, we are dividing. 24 divided by 2 would give us 12. So if we're doing that on the denominator, we have to do the same in the numerator. 18 divided by 2 is 9. So that fraction would be 9/12. Same thing over here. Start with the fraction you know and move to the fraction that you don't know. To get to from 6 to 42, 6 times 7 is 42. We're getting larger, so I know we're multiplying. Whatever we do in the numerator, we have to do in the denominator. So 7 times 7 is 49. So our equivalent fraction is 42 over 49. Next, we know 9 over 45, so we're moving to the left. We're getting smaller, so I know we're dividing. 15, if you're not sure, count up how many 15s would go into 45, and it would be 3. 45 divided by 3 would give us 15. So 9 divided by 3, oopsies, 9 divided by 3 would give us 3. 3 goes into 9 3 times. So that fraction is 3 over 15. This last one, I want you to click pause and then click play when you are ready to check your work. So we have 8 over 14. We're moving to 16. That's getting bigger, so I know we're multiplying. 8 times 2 is 16. Same thing on the denominator. 14 times 2. If you're not sure, multiply it out. 4 times 2 is 8. 2 times 1 is 2. Gives us 28. So again, start with the fraction that you already know. Then work to the one that you need to find. If you have any questions,